Now, in advance, I want to tell you one thing, and that one thing is that this calculation is very lengthier, and there are so many complex integrals involved. If I do solve all the integrals here, then this lecture will exceed 4 hours. But in order to uh, discuss the content of the lecture and the concept behind all these calculation, our lecture will be more focused on that one. Now what we will do with the integral solution, because the integral solution is also part of the lecture, so I will provide you all those solution in the lecture notes. So inside this lecture, when you will go to the lecture description, inside the description I usually paste the link to the lecture notes, and inside the lecture notes all those integrals are being solved step by step, so there is nothing to worry about those complex integrals. And for each of them I will tell you that I have provided the step-by-step solution of this integral within the lecture notes, so that is not to worry. So let's start with this one now, that we are going to calculate VEE. Now this electron repulsion term is equal to, just put this thing equal to psi, the psi that we have written, psi naught VEE and psi, and this is equal to E square, the constant term, over 4 pi epsilon naught. This term we are having from here, E square over 4 pi epsilon naught, and then we are having in the psi, we are having 8 over pi a cube, so it will become 8 over pi a cube, and it will become square because we are basically psi naught is being multiplied with psi naught, so we have this thing equal to square, and then we will have the integral, and inside the integral now the next part will be the exponential part. So here e to the power minus 2, now is this one is having no iota involved, so it means it will be a simple square. When I square this thing, then minus 2 will become minus 4, so minus 4 in r1 plus r2 over a, and then this is divided by, we are having the VEE terms, VEE e square 4 pi epsilon naught we have written, and this 1 over r1 minus r2 term is there, and then there will be the integration terms, so we are having r1 and r2, so we will have the volume element of d cube r1 and d cube r2. So it's a very complex integral, lengthy integral, and we will have to further solve this thing step by step. Now what we do, we basically try to focus on R2. We solve the whole integral first for R2, then whatever the solution comes in, we will put that solution back into this, and then we will solve it for R1. So that is the way we will proceed, and in order to solve it for R2, we are trying to align the coordinate system such that the R1 is along Z2. So our figure, the orientation of the figure will be something like this, that we are having here x2, y2 and z2 here, and then we orient the r1. This is the r2. Let me orient this one. This is r1, not r2. This is r1 and it is along the z2, and the r2 is like this. Sub r2 is here, and then because this is one electron that we are having, and this is another electron, these are the coordinates of the electron, and then this distance which will be from here to here is r1 minus r2 from simple vector addition. Then this angle is theta 2, and when we will have the projection of this vector, then this vector projection is phi 2, because we will utilize the spherical polar coordinates here. Now, based on this, I can write that r1 minus r2, this absolute value from the law of cosine, I can write is r1 square plus r2 square minus 2 r1 r2 and cos of the angle between r1 and r2, which is cos theta 2, and this will become a square root because we are writing it like this. So simply from the law of cosine we have written this thing. Then if I look to this integral, then in this integral we have like the whole integral, and I only want to focus on r2, so I will have the I2 integral. This is the I2 integral is equal to from e minus 4 r2 over a, because I am not writing r1, only focusing on r2, and then divide by r1 minus r2. Because I can break this thing, I can write this e power minus 4 r1 over a multiplied with e to the power minus 4 r2 over a, and one with d cube r1 and other with d cube r2. So minus 4 r2 over a, and then this will be d cube r2. So this way we are going to solve this integral. So I2 I will write first. This implies that I2, now I will write R1 R2 value here. So integral and e to the power minus 4 R2 over a divide by, this is r1 square plus r2 square minus 2 r1 r2 and cos theta 2, and this is square root and d cube r2. So we have this thing, and it is also good to write this d cube r2. This is the volume element for r2, so this will be equal to e power minus 4 r2 over a, and this is r1 square plus r2 square minus 2 r1 r2 and cos theta 2, and this is half, and write the d cube r2. So we know the volume element for the spherical polar coordinates. It is r dr sine theta d theta and d phi. So I will write in terms of r2, so r2 dr2, then sine theta 2, d theta 2, and d phi 2 here. So I have written the volume element as well, okay, and this is not r dr, but this is r square dr sine theta d theta and d phi. So I have written the integral over here. Now if I look at the integral, then the integral over d phi is very easy, and it just gives 2 pi. While if I look at the integral of theta, then I will have to calculate this integral. So inside this integral, I have another integral to solve first. Like for theta 2, I will have to solve this first, and then this integral is equal to let me write the theta integral first. So the theta integral, so for theta integral, I know that theta is running from 0 to pi. So I will have the integral, and let's say if we call this, this is I2, so let me call this I2a. And then this integral is equal, this is part of this integral, so we have from 0 to pi, and only write sine theta d theta this. So this one means the r I will leave now, I will just go toward theta, so I will write this thing is r1 square plus r2 square minus 2 r1 r2 and cos of theta 2, and this will become minus half, the exponential term is not coming in here, and then sine theta 2 and d theta 2. So I will have to solve this integral first, and to solve this integral, we know one basic formula, and the basic formula is that if we are having the integral of like f of x, and this is to the power n, and in front of it its derivative is existing, then what we do, we basically write this f of x, and this become n plus 1 over n plus 1, and we also derivate the x integral here as well. Whatever the domain of it, we do the integration of that thing as well. So this thing will come out to be equal, the I2a will come out to be equal, this will become, look here, if I look here to this one, then what is this? This is our f of x to the power n. Now look here, if I look this first term with respect to theta, then this is equal to 0, this is 0, and this one, if I do skip this one, then cos theta 2 integral is the differential of cos theta is minus sine theta. So it means in front of the function its derivative is present, and we can apply this. So it will become function, so this is the function, minus 1 over 2 plus 1, so it will become 1 over 2, and then it will be divided by 1 over 2, the result will come out to be 1 over 2. Then we will have to differentiate this one as well with respect to the x, then differentiate this with respect to theta, then what you will get, we will get minus 2 r1 r2, and that 1 minus that 1 2 will cancel with because from here the power we would have got 1 over 2, and then 2 will come from here, so we will get only R1 and R2. And I am writing that thing over here, that this will come out to be